Hello everyone and welcome to another video. In this video we are going to fix the PS4 controller stick drift problem. As you can see on the screen, both of the analogs are drifting and we are going to completely remove them and put the new kind of analog, the Hall effect one. They are totally invincible to the stick drifts and you can use them for a long time after changing them. You are going to need a soldering station for this, and screwdriver, opening tool, and some simple tools. Next to the soldering station, we need some flux and low melting point solder so we can easily remove the analogs without damaging the board. If you are a hardcore gamer, I bet that you buy controllers every couple of months because of the stick drift problem that makes the controller completely useless. And let me tell you that companies that made these controllers, they are doing this on purpose. So every time the controller breaks, you have to buy a new one, and they are very expensive, $60 to $100 for a controller. And this is a solid investment to just buy a soldering station and some simple tools. And every time the controller breaks, you can fix it for yourself. And this comes very cheap. I bought these analogs for about $1.50 or $2 each, so this fix cost me about $5 max, and you get a free dopamine hit for fixing this afterward, so totally worth it. Also, if you have a rubber problem, you can just open this and access the rubbers and change them. If some of the controller's button don't work, like the rubber is fine but you press the button, the button don't work, the root cause of that problem is this ribbon flat. They are usually come in green or blue. You can just clean this spot a little bit with water or the board spray, but do not use the heavy chemicals as they can completely damage the ribbon flat and you have to change it completely. The analog itself has 8 pins that we have to solder and remove, uh, and these potentiometers has 6. So it is better to remove the potentiometer one by one so we can remove the analog easier. I have access to hot air and I can just use it to remove the analogs easily, but I do not recommend it as it can damage the motherboard, move the CPU around, or even the small parts, and that will make our work just harder. So I'm going to add a bit of flux to the potentiometer's legs and remove them one by one. I also add a bit of low melting point solder to the legs so we can remove the potentiometers easily, because the old solder that are connected the potentiometers are hardened and hard to melt. Now that we have removed all four potentiometers, let's bring our desoldering tool and remove those solders from the PCB so we can put the new analog easily in place. I put this part in the fast forward because there is nothing special to watch. You can slow down the video if you have problem desoldering. Now that we have removed all four potentiometers, we are going to remove those two analogs and our work is done. After that, we can easily solder the new analog. So I add a bit of flux to the legs. After that, I bring my desoldering tool and try to desolder the old solders so I can later apply low melting point solder, and that will give me enough time to heat all of the joints and remove the analog. So I removed all of the old joints, and I'm going to add a low melting point solder. As you may already noticed, those four small pins, small legs, are desoldered successfully, but these four larger ones are hard to desolder, so I'm going to brute force. I bring a small screwdriver and put it beneath the PCB and the analog, and then I hit the legs and slowly push the screwdriver inside and pull the legs inside. I am happy with my desoldering tool. It is slow but gets the work done. And if you are very serious about this work and you want to buy a station, check out these 2-in-1 stations that have the soldering and desoldering all in one, and they are so cool. So if you want to invest on something cool, and this will make your work 10 times faster because they are automatic and have a pump inside of them, so you don't have to charge the tool each time you are going to use it. Be careful how you put the screwdriver inside. Some parts of the PCB have very small SMD parts, and the last thing you want is to damage them. They are very hard to solder back again. That is if they don't break in the first place. So always check the back of the PCB and use the screwdriver where it has no SMD parts. By the way, if you have those desoldering stations, they can remove the solder very easily, and you don't need to do any of these parts. Okay, after 5 minutes soldering, one of them is out, but I'm not going to show you the other one. This is boring for you, I know. Let's desolder the PCB so we can place the new analog easily. Don't spray these cleaners on those two big chips, the MCU and the charging chip. So when soldering, I'm going to solder the big leg first, only one of them, not the rest of them, because sometimes they can be faulty, the magnetic analogs can be faulty, and this is very rare, 1 in 100, but it can still happen. So it's better to check it first and then completely solder them. We are also going to solder the magnetic potentiometers only and not the other legs. So the best way to test the analog is on the PCB. There is no better way to test it. So we have to do this risk. I have connected the controller via USB to the computer, and I have launched this website to test the controller online. And as you can see, the right joystick, the right analog is fine, but the left one pulls right downward a bit. So we are going to adjust it using this sharp needle. As you can see, this is a sharp needle and there is two holes on the analog. We are going to insert the needle in one of them while pulling the analog up. So let me quickly sacrifice one of these things to show you what is exactly inside. Okay, this is the sensor and two holes in here for the adjusting of the magnet, and that is the magnet and the analog. So when we bend the analog in this direction, the magnet goes in the opposite one, and the needle goes here. Oh, it comes off. Okay, the needle goes here, and when we let go of the analog, the magnet move a bit to that side, and that's how we can adjust the analog. Okay, this looks fine. The analog is working perfectly and it is centered exactly how I wanted, and I have also soldered those other parts, other legs of the analog. So let's just close everything up and solder these 4 wires. And be careful with this blue flat. If you put this in the opposite direction, the controller won't turn on and you have to open it again. Now with the magnetic analog inserted, this controller will never drift again. Let's see if it turns on and close the screws afterward. Yes, it is fine. And look at you, you have watched this video until the end. Thank you very much. Don't forget to like and subscribe if you enjoy this content. It will be appreciated. I will see you in the next video.